This is a demonstration of the AeroMarine Research Vee Boat Design Program version 8.9. I'm Jim Russell, and this is a quick video to show how easy it is to use this software to get a highly accurate prediction of the performance changes with varying Vee Deadrise design of your boat. Let's get right to the operation by going straight to the first screen and selecting our Vee hull design model. This selection already has all of its design specifications entered properly on the 5 input screens. My base hull design setup is an 18.5-foot Vee hull with 25-degree deadrise and powered by a 175 horsepower Mercury Verado outboard. There are lots of input variables where we can fine-tune our design to show the exact hull design we're working with. I'll now show you just how fast and easy it is to do a performance analysis using the Auto 123 wizard. First, I want Vee Boat Design Program to predict my maximum speed, so I'll go to the setup screen and I'll check the 123 analysis box. This automates the calculation of maximum velocity for my setup and horsepower available. Now I'll just click Calc Perform to get maximum velocity. And there it is. This is the report wizard, and it gives me a summary of all kinds of performance information. Right now, I'm interested that the report is telling me that my maximum limiting velocity is 60 miles an hour. Now I'm ready to go to step 2 of the performance analysis, so all I need to do is click on Add Vmax. The Auto 123 wizard has now set the maximum velocity and will set the performance analysis method to automatically adjust the operating trim angles required through the entire velocity range. Now I can click on Calc Perform again, and I get the completed performance analysis starting with the report wizard. This version of the report wizard is really outstanding. The wizard has reviewed the detailed performance results for all of the entire velocity range. The report's full of key performance measures and advice that's specific to my hull design and this setup. There are other videos that describe all the details of the report wizard, but I want to show you just how we can use the software now to compare the performance of hulls of different Deadrise designs. The report shows us the maximum velocity of 60 miles an hour, all the different drag contributors, discussion on dynamic stability, and on porpoising of the design. I can click Details and get the full performance output screens that show how this design behaves through its entire velocity range. And I can see it all in graphic format too. For example, the trim angle graph shows the required change in trim angle at each velocity. Our 25-degree Deadrise hull starts out at a trim angle of 1.7 degrees at 25 miles an hour and needs 5.6 degrees trim at its top speed of 60 miles an hour. Or we can see at what velocity this design might be susceptible to porpoising. The part of the line on the graph that is bigger than 1 is in the green stable region, and any velocity below this line is in the red porpoising instability region. Our design just starts becoming susceptible to porpoising at around 60 miles an hour. Now I'm going to save this performance of our 25-degree Deadrise design and then return to the input screens to test another design. I'm only going to change one dimension, the Vee Deadrise from 25 degrees to 19 degrees. Then I'll just click Calc Perform again and look at the new performance result. We get the report wizard again, this time showing results for our modified design with additional information about predicted performance differences. For example, the software has determined that the modified design of 19 degrees Deadrise V will have a top speed that is 4.1 miles an hour faster than our first design with the higher Deadrise. I can now click Details again, and I get the full performance output screens that will now show all the performance characteristics of both designs, all in graphic format. I'll go straight to the performance graphs and see that the trim angle comparison shows that the 19-degree Deadrise design is more efficient for top speed and can achieve 60 miles an hour with a trim angle of 4.3 degrees, where the original 25-degree Deadrise design achieved only 56 miles an hour at the same trim angle of 4.3 degrees. Another example is the porpoising graph comparison. Remember that results above the pink line are stable and results below the pink line are in the porpoising instability zone. Our 19-degree Vee hull becomes susceptible to porpoising at around 48 miles an hour, and our 25-degree Vee hull doesn't see any porpoising until after 60 miles an hour, so the lower Deadrise design is more susceptible to porpoising. So we've just looked at 2 of the performance results when comparing our 25-degree Deadrise Vee hull with a 19-degree Vee hull. In short, the 19-degree hull is faster, but also more susceptible to possible porpoising behavior at mid-range velocities. That's how easy it is to compare these 2 designs based on just changing hull Deadrise angle. I'm now going back to the design input screens. There's a lot that we can learn about the performance of any boat by trying different designs, dimensions, or setups, and we can see the results quickly on all the screens of the Vee Boat Design Program.